is very similar to cooking, as mentioned in the previous session of class number 4. In the chemical route, the main ingredients are metal compound, which is usually a positively charged metal salt, and metal salt that is dissolved in an appropriate solvent and introduced as a reducing agent. By using surface controlling agents, very uniform particle sizes in the nanometer range could be obtained. The last ingredient is the stabilization agent. Adding a stabilizing agent into this solution prevents uncontrollable growth of the nanoparticles, control over the growth rate, and also the particle size. Also, it can prevent agglomeration of the nanoparticles and can make the nanoparticles soluble in desired solvent of interest. In the present slide, you can see a short video that illustrates the formation of gold nanoparticles by means of chemical route. While you enjoy the experimental procedure and the nice music, I would like to notify a few points. Colors change. So far, the chemical route for nanoparticle synthesis in the last few slides is suitable for the formation of bare nanoparticles or nanoparticles without any organic lesions on their surface. For the formation of metal nanoparticles that are encapsulated with organic lesions, it is common to use the precipitation method or the so-called roast method. The strategy of this method is the chemically bonding of a thiol ligand monomer on the surface of the gold nanoparticles during its formation. This reaction is referred to as attachment of self-assembly thiolated monomer, since it happens with no external help. The bond between the thiolated molecule to the gold surface is a covalent bond, which is extremely strong. The roast method can be used to produce gold nanoparticles in organic liquids that are normally not miscible in water, such as in the case of toluene. It involves the reaction of chloric acid solution, or HAUCl4 solution, with tetraoctyl ammonium bromide, which abbreviated usually to AB, in toluene. These 2AB actually serve as a phase transfer agent from water to the organic solvent. And on the other hand, we use as further ingredient a sodium borohydrate, which serve as a reducing agent for the reaction. More specifically, when adding the 2AB dissolved solution in an organic phase to gold ions in water, the interaction with the gold ions transfer the gold to the organic solvent. In the organic solvent, the self-assembly of thiol molecules can form on the surface of the nanoparticles, and the sodium borohydrate serve as a source for electrons that is needed for the reaction. It is important to note that 2AB does not bind to the gold nanoparticles particularly strongly, so the solution itself will aggregate gradually over the course of approximately 2 weeks. To prevent this, one can add stronger binding agent like a thiol, which will bind to the gold, producing a near-permanent solution. Alkane thiols protected gold nanoparticles can be precipitated and then redissolved. Some of the phase transfer agent may remain bound to the purified nanoparticles, something that may affect the physical properties of such nanoparticle solution, such as the solubility of the nanoparticles. In order to remove as much of this agent, the nanoparticles must be further purified by the so-called extraction methods. Synthesis approaches are also available for controlling the shape of the nanoparticle type. Shape control is commonly achieved throughout a two-step process termed seed-mediated growth. In the first step of the seed-mediated growth, a very small, uniform, spherical seed particles are generated. These seeds are composed of densely packed atoms with different facets and boundaries at the surface. Some facets or boundaries are energetically stable due to the direction of their facets or due to the fact that the organic molecules are adsorbed on their surface, such as in the yellow area shown in panel A of the presented figure. On the other hand, other facets on the same metallic surface seen are less stable due to the direction of their facets or due to the lack of stabilizing agents at their surfaces. Facets that are less energetically stable have higher motivation to keep growing and adding new atoms to them than the others. Therefore, by controlling the reaction conditions, more metal ions are added to the specific unstable places on the nanoparticle surface, thus resulting larger particles of particular morphologies or habits. Typically, the growth stage is much slower and proceeds under milder reducing conditions than the nucleation stage. With this slide, we now reach the end of class number 4, session number 2. Thank you.